Hello everyone. In this video, I'm going through question number 2 from the AQA 2018 paper 1 higher tier for the combined science physics. This question is on the topic of particle model of matter. Question number 2. A student wanted to determine the density of the irregular object shown in figure 2. Now, this object, which looks like a chess piece of a horse's head, is an irregular shaped object, so which means you will have to use an indirect method to measure the volume. So plan an experiment that would allow the student to determine the density of the object. Now remember, density rho is the mass divided by the volume. Now if you can figure out the mass and then figure out the volume of this object, then you divide those two values to get the density. That's what the question is about. For 6 marks, you need to describe how to measure the mass and then how to measure the volume and then state this equation. So the easiest part is to measure the mass. You simply use a weighing scale and measure the mass in grams or in kilograms. If you measure it in grams, then you can measure the volume in centimeter cube, and the density that you would get would be in grams per centimeter cube. And if you want to measure it in kilograms, then you'll have to measure the volume in meter cube. Because it's a small piece, we'd rather actually give the density in gram per centimeter cube. So for the first point, right, I would write density can be calculated using the equation density equals mass divided by the volume. Let's start off with the equation first, and then we can describe how to measure the mass then. Like measure the mass of the object using a top pan balance or weighing scales, right? And we can say in grams. Next part is to describe how to find the volume. Now, because it's a irregular object, if it was a regular object, you would measure the length, width, and the height of the object and multiply those three values to find the volume. Here, because it's an irregular object, you need to use what is called a displacement can or a eureka can. So to find the volume of the object, fill a displacement or eureka can with water. Right? The water level should be in level with the spout level. Then place the object in the water and collect the displaced water in a measuring cylinder. The volume of displaced water is equal to the volume of the object. And then you would have the volume. Now, there's another way of measuring the volume, right? Although this probably depends on the size of the object. You could part fill a measuring cylinder with water, measure the initial volume, and place the object in the water. So measure the initial volume, let's say it's 10 centimeter cube, and once you place the object, if the volume level goes up, measure the final volume, let's say it goes up to 15, then you can work out the difference. Volume of the object will be final volume minus the initial volume. So if it went from 10 to 15, the difference is 5 centimeter cube, which should be equal to the volume of the object. And that should give you the 6 marks. Now, if you have forgotten what a eureka can actually looks like, we can also use simple diagrams as part of the answer. So a eureka can is shaped like that. That bit is the spout, and when you fill it with water, the maximum level of water that you can, oh, it's actually going to a straight line. Okay, right. That is the level of water that you can actually fill with. Now, if that's the object that you are trying to measure the volume of, if you place that, then the water will actually go up, and the water that comes out can be collected using a measuring cylinder, right? So that's your displacement can, your measuring cylinder, and the volume of water collected is equal to the volume of the object. Next question, 2.2. Another student did a similar experiment. He determined the density of 5 common plastic materials. Table 1 shows his results. So the plastic materials tested was acrylic, nylon, polyester, polystyrene, and PVC, and they have given you the density in kilogram meter cube, right? Now, figure 4 shows the results plotted in a bar chart. So you got density and the different materials. Complete figure 4, you should write the correct scale on the y-axis. Now, for the y-axis, you need to write numbers along this line. So the easiest, if you look at nylon, it's actually 1000. So nylon over here, that bit is 1000. Now, if you can see the dark line, that's halfway point. So that would be 500, 0 there, and that's 1500. Now, you don't have to label any more in between. That's more than enough. But if you were to count the number of boxes from here to there, that's 10 boxes there. So each box is 50. Should be 50, isn't it? Yeah, 50. So that's 250. So 50, 100, 150, 200, 250, yes. Right? So for acrylic, it was 1200. So you can see it's gone from 1000 and then 4 boxes up for 1200. How do you draw the bars for polyester, polystyrene, and PVC? So let me bring in my pre-drawn shapes. So for polyester, right, I'm drawing the bars. So as you can see, there's 3 boxes on the left and on the right for both of them. So I've left 3 boxes on both sides. The width of the box is similar, so I maintained that width, and it's 1380. So it's going to be very hard to actually get it very accurate because of the scale, but this should be okay, right? It's nearly 1400 here. The next one is 1040. So it should be, for polyester, it should be nearly 1 box higher than what you have for nylon. And for PVC is 1100. So it should be 2 boxes up. There you go. 2 boxes up. And that would give you the 4 marks. The marking scheme gives you marks for all. Y-axis should have correct values, and there should be a minimum of 3 values. So let me bring the marking scheme guidance here so that you can actually see what they're expecting. So all y-axis values correct, minimum of 3. Allow 1 mark for 2 correct values. All bars drawn to the correct height. Allow 1 mark for 2 correct bars. Allow plus or minus half small square. So that's a tolerance level as well. Next question, question 2.3. The student is given a piece of different plastic material. The student determined the density of the material 3 times. So they worked it out 3 times. Here's the value. Determine the uncertainty in the student's results. How do you work out the uncertainty? Now, you look at the maximum value and the minimum value, right? So the maximum value is 1040. No, that's the maximum value is 1120. So 1120, take away the minimum value, which is 960. That gives me, so let's do that, 1120, take away 960, it gives me 160. Divide that by 2, it gives me 80. So the uncertainty is plus or minus. So if we find the mean, the mode or the middle point, the highest value is plus 80 or the lowest is minus 80. That's what our uncertainty is. So we don't have to write the plus or minus, but it's 80 kilogram per meter cube. That's the end of question number 2. I will see you in question number 3. Thank you.